السلام عليكم. لا تنسوا الإعجاب بالفيديو والاشتراك في القناة تشجيعا لنا لنستمر بنشر المزيد إن شاء الله.
Canola oil is a commonly used type of cooking oil. It's derived from the seed of the canola plant, which North American farmers have been growing for about 30 years. The plant blooms in the summer, producing bright yellow flowers. Farmers harvest the seeds from pods, which form after those flowers die off. Canola oil is one of the healthiest cooking oils. Compared to olive, sunflower, and soybean oils, it has the lowest level of saturated fat, 7%. It also contains more healthy omega-3 fatty acids and is high in monounsaturated fat, which lowers cholesterol. When the canola seed arrives at the processing factory, it contains foreign material, mostly plant pieces. So the first step is to clean the seed in a vibrating sieve. The seeds, smaller than the openings in the sieve's mesh, fall through to a conveyor below. The foreign material remains on top. A conveyor moves it to a storage bin where it's collected for sale as cattle feed. The seeds pass by a magnet. It removes any metal that may have fallen in during the journey from field to factory. Next, the seeds enter a roller mill. They pass between two steel rollers, which crush them into thin flakes. A conveyor then feeds the flakes into a screw press. It has a large revolving screw-shaped shaft enclosed within a slotted cage. As the shaft turns, its threads squeeze the flakes with high pressure, forcing out the oil, which then drains out through the slots. 42% of canola seed is oil. This screw press extracts nearly 3/4 of that. The remainder is still trapped in the pressed flakes, now referred to as canola cake. The cake exits the other end of the press and moves on to a second extraction. This one, a 70-minute wash with a solvent. This chemical extraction process removes all but a trace of oil. The factory then grinds the cake into protein-rich meal, which it sells as animal feed. The extracted oil, stored in large tanks, now enters the refining phase. First, they wash the oil for 20 minutes with sodium hydroxide. During this wash cycle, they spin the oil at high speed so that the centrifugal force separates the natural impurities, which the factory later sells to soap manufacturers. After this cleaning process, the canola oil is visibly clearer. However, it still contains natural waxes, which make it look cloudy. So the next step is to cool the oil to 5 degrees Celsius. This thickens those waxes so they can be filtered out. The waxes don't go to waste either. The factory uses them to produce vegetable shortening. In the factory's lab, technicians recreate production on a small scale to ensure performance and quality. Meanwhile, back in the factory, after washing and filtering the oil, they bleach it to lighten the color, then use a steam injection heating process to remove the canola odor. The oil is now fully refined and ready for bottling. The equipment first turns the plastic bottles upside down and injects filtered pressurized air to blow out any dust or dirt inside. Then it turns the bottles right side up again to position for filling. Just before a nozzle starts filling, it applies a vacuum. If there's no suction indicating a leak in the bottle, the machine automatically ejects that bottle from the line. Each bottling machine in the factory fills 22,000 bottles per hour. The labeling machines work at the same speed. They spread glue on the back of each label, then apply the label's edge to the bottle. The bottle spins, wrapping the rest of the label around itself. As the bottles come off the labeler, a robot separates them into groups of 12. Then it picks up and deposits each dozen in a shipping box. From field to factory to your pantry, where once opened, canola oil has a shelf life of about a year. Food just slides off non-stick cookware's remarkably slippery surface. In 1938, an American chemist was experimenting with refrigeration gases. A waxy substance formed. Years later, when bonded to cookware, it gained a non-stick reputation. When it's time to fry, using a non-stick pan averts a messy situation. The non-stick coating is one of the slipperiest solid materials on Earth. Called polytetrafluoroethylene, the name is a bit of a mouthful, but the appeal is simple. Food won't get stuck on this non-stick surface. To make the aluminum pan, they use 70% raw material and 30% leftovers from prior production of pots and pans. They fire it to a molten state and filter it to remove contaminants. The liquid aluminum flows into vertical rectangular molds. A jacket of water around the molds cools the aluminum to take it from a liquid to a solid. A crane extracts the cast slabs. They're heading to a heating chamber to soften the slabs. This will allow the metal to be shaped and formed. A saw slices the slabs in two and trims the ends. More blades scrape the top and bottom to remove impurities. A conveyor repeatedly feeds the shorter slabs to heated rollers. Guides at the side maintain the width, while the rollers compress the aluminum, taking the thickness down to about ½ centimeter. The rolling also elongates the slab substantially. It starts out 2 meters long, and after a few minutes of rolling, it's been stretched to well over 100 meters. Pizza cutter-style blades trim the edges of the aluminum sheet. Another roller winds the aluminum into a big coil. Then they unwind it and squeeze the aluminum to flatten it. Machinery now pulls the long aluminum sheet forward to a 120-ton punch press. This powerful press forces the metal around a frying pan-shaped die and then punches out the shape. The freshly formed aluminum frying pan falls onto a conveyor below. The leftover aluminum will be used to make new frying pans. The pans now ride a conveyor through a washing station, where they're cleaned and then treated with sodium hydroxide. This opens the pores of the metal to allow an enamel coating to stick to the outside and the non-stick finish to adhere to the inside. A worker inspects the pans and places them upside down on spray fixtures. It's a tight fit to shield the inside from the enamel spray that comes next. The pans spin on the fixtures and twirl by the spray nozzles for an even application of enamel to the exterior of the pans. A glossy clear coat follows. The frying pans transfer to a dryer conveyor. The hot air pulls out water from the enamel coating, and the color goes from gray to chalky white. An automated squeegee silk screens the company name and other information onto the pan bottoms. They now enter a long curing oven, heated to 560 degrees Celsius. The cure toughens the enamel, deepens the color, so it turns gray again, and it adds gloss. A suctioning device picks up the pan and turns it around for the inside coatings. A sprayer applies a special primer that will make the non-stick coating adhere to the pan. It then applies the non-stick coating. The pans receive 2 layers of this non-stick synthetic substance. The suctioning device releases the pan and it lands upside down. Then, the pans journey through the oven again to cure the non-stick finish at around 425 degrees Celsius. On exit, water rains down to cool the pans and rinse off any contaminants. Then they go through an infrared light chamber to dry off. From a plain shell to a pan with an enamel finish on the outside and a non-stick coating on the inside, the transformation has taken just 1 hour. A worker now aims a laser and aligns it with lettering on the bottom, allowing him to punch holes in a precise location on the side of the pan. He slides pins into the holes and slots them through holes in the handle fitting. Using a ram, he flattens the pins to rivet the handle to the pan. Now, no matter what's cooking, cleanup should go smoothly.